Hello everybody, I will start my today's coding practice. So today's question is this one. Sort an array. So this is a, quite a simple question. Yeah, and typical famous, yeah, I think one of the most frequently asked question in the coding interviews. But let me, get back to the fundamental and let me solve this question. So given an array of integers num, sort the array in ascending order and return it. You must solve the problem without using any built-in functions, and it has to be n log n time complexity, yeah, with smallest space complexity possible. Okay, so I will introduce two sorting algorithms today. The first one is QuickSort, and also I will solve this question with MergeSort. Okay, so I will let me get started with QuickSort because actually in the last 2 days I did quick select. Yeah, and I used it for get the case largest number in the array. But today in this question I will use it for use a similar technique, partitioning and recursion with sorting an array. So let me quickly introduce the idea how I can do it. Okay, so assuming that I'm given this array like this, in the quick select, I will do the idea of partitioning. So for example, let me do it. Okay. So the main idea is I will arrange the array with this way. So I will pick up the pivot number, then all numbers smaller than the pivot number should come to the first half. And any number which is larger than the pivot number, I should say larger or equal to the pivot number, should come later than the pivot number. And in that way, what I can say is this 3 is exactly at the correct position. This 3 is now at the position it should be after the sorting. And for this first half, I have to do the same thing again and again recursively. And finally, they will be, all of the numbers there should be in the position where it should be after the sorting. And for numbers greater than 3, pivot number, I can do the same. So this operation, I put the number somewhere and numbers before that should be smaller and numbers after that would be larger. So this operation is called partitioning. And in the quick sort, I will do this partitioning multiple times, recursively. Yeah. And the time complexity would be n log n. Average. And in the worst case, it should be n squared. And for space complexity, it should be basically, on average, it should be log n. And in the worst case, it should be O of n. So what I mean by average case and worst case is that, think of the case when I pick the pivot number, and unfortunately, every time I pick the pivot number, it is the largest one. In that case, I will have to do the recursion n times, because in each step, the range I should sort is, narrowed down by 1. And in total, I have to do the iteration, recursion n times. So in that case, this is the worst case, and it should, yeah. And, oh, I didn't say this, but actually partitioning can be done in the linear type. And assuming that if I narrow down this code by one, it will be n plus n minus 1 plus n minus 2 plus blah 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 1, so it should be n squared. Yeah, but on average, since that the scope is narrowed down by half, so in that case, how many times do I have to do the recursion? It should be log n. Since that this length is divided by 2 by every recursive function call. So in the end, number of recursions should be log n. And for each recursion, in total, I have to sort in total n element. Yeah, the sum of this line 18 should be n. So in that way, the average time complexity should be n log n. Yeah, and for the space complexity, the space I need is only the recursion stack, and aside from that, I will mutate the array, given array, and sort it. So as I said, on average recursion number of recursion should be log n, so it should be the space complexity, and in the worst case, it should be O of n, which should be the space complexity. Okay, that being said, let me start the implementation. I will use the function so this is a helper function which mutates the array num and sorts this range from low to high. So this is the helper function. So what I should do is call this first in the main method, then I will return num array. Yeah. So let me start the implementation of sort. Firstly, I will pick the pivot number as the last element, last index high. So that being said, the pivot number should be this. And after that, let me show this with this example. Assuming this, I will think of two, pointers, reader and writer. And reader will take a look at each number from head. Then, if the number there is smaller than the pivot number 3, then it will swap that number with writer position number. So let me do with this example. In this case, pivot number is 3 and reader comes is 4, which is larger than 3, so I don't do anything. But if reader is at 1, it is smaller than 3, I will swap reader and writer. Then I will increment the writer position by 1, because now writer position is number smaller than 3 pivot, so I don't want to update this position anymore. So this is how it works. So reader goes to 5, but it's larger than pivot, and then reader goes to 2, which is more than pivot, so I will swap. Then I will move writer position by 1, and that's the end. I don't, yeah, the last number is the pivot number, so I will then swap writer number and pivot number. So it should like this, and now I can say, so pivot position is index 2, and numbers before that is smaller than the pivot number 3, and numbers after that pivot number is larger or equal. Okay, so let me implement this. So then I will write it, and finally I will. Oh, sorry, the pivot index should be high. Okay, so this is how it is done. So from here, what I will do is, oh, sorry, I forgot to tell something. Basically, this is, okay, yeah. So now W is the pivot index. And as I said, I will recursively sort numbers before pivot index and numbers after pivot index. So basically I will do this. However, as the base case, here, if low is equal to high, I don't have to do anything more. Because if number of element is 1, it already sorted. Yeah, so that's the main idea of QuickSort. Let me run my code. Okay. Sorry, wait. Oh, I don't have so much time today, so let me keep walking through my code. Ah, wait a minute. So, W. Sorry, if reader number is smaller than the pivot number, hmm. Ah, I see. So still, with this, assuming that the low is 2 and high is 3, pivot number, I mean, pivot, yeah, in this case, this is array, and low is here, high is here, and maybe pivot is here or here, low or high. In either case, what happens is that, assuming that now pivot is high, in the line 55, it will call with pivot plus 1 to high, and which means that low is higher than high. So it doesn't, I mean, the term in, I mean, base case condition doesn't catch that case. So what I should do is this. If low is equal to high or higher, in that case, I will return. Okay, good. Now where are my code? And unfortunately, this is not accepted in the worst case, n squared. So there is a way to avoid this problem as an optimization. There is to pick the random number as the pivot number. I mean, random index in the range of low to high should be picked up as a pivot number. So I can do it in this way. So in this way, I will pick the random number as the pivot number, and then I will move it to the high position, which is the last position in the range. Okay. Random int. So let me try with this. Oh, it still doesn't work. And the reason is that in this case, all of the numbers look like 2. I don't know. In this case, pivot number is always picked as the second, last index. So it ends up with narrowing down the scope by 1 every time. So the optimization I can make is, if I find this all the numbers are 2 in this way, I will choose pivot number, and it should be somewhere in the middle in the end. Yeah, so that's what I would like to achieve. So what I should do is in line 57, if pivot number is equal to the reader number, I will move it to the, I will make a swap in 50% probability. So I can do it in this way. Yeah, like this. So if numbers are the same in the 50% probability with kind of drag, which is named pivot, which is named swap, I will decide if I should swap or not. Yeah. So let me run my code with this. Oh, sorry. Now it failed. Let me take a look. Ah, sorry. Else if. Oh, sorry. No, it should be like this. Ah, sorry. I should compare with the pivot number here. Okay, and now my solution is accepted. So I could avoid the case when the time complexity n squared, which is the worst case. Okay, so now I will introduce the MergeSort approach. Okay. So basically, this also takes n log n time. I will tell you why. And also, for space complexity, it will take O n basically. So the basic approach idea of MergeSort is I will be given the array like this, and I will split the array into half all the time. And basic assumption or idea I have in my mind is, if I'm given two arrays, which is each of them are sorted like this, I can sort this array, two arrays, into one sorted array in O of n time. N is the total number of elements. Yeah, because I can use the 2 pointers. Yeah. And I will compare P1 and P2, and if P1 is smaller, I will pick some number, and then I will move the P point to 1. And if they're the same, I will pick the P1 number. And if P2 is smaller, then I will pick the P2 number and move the P2 pointer. So in this way, with 2 pointers, it will take only O of n time. And that being said, okay, then I will tell you how. So I will do the recursion, and every recursive function, I will split the array into 2, whose each of the ranks are the same. Then I will continue this until the function is called with rank 1. Yeah. So if the rank is 1, I don't have to sort it. I mean, I don't have to merge it with. Okay, so sorry. I mean, if the rank is 1, it means that this array is already sorted because number of elements is only 1. And basically, based on that, here in line 8, I will merge 2 result array, each of whose rank is 1, into 1. Then I will do it recursively, yeah, in the caller. So this is how it works. And I can say the time complexity is exactly the total ranks of this arrow, all of these arrows. Yeah, because, oh, minus this one, aside from this one. This, and this. And that being said, the height, of this recursive function should be log n, because every time that the array is split into 2, yeah, so the length of the range would be narrowed down by half all the time. And that being said, the time complexity should be n log n, because each row, total length of the arrows should be n, so it should be n log n. And for space complexity, what I need is, so firstly, recursion stack. So for the recursion stack, as I said, number of recursion should be log n. They should be log n. However, when I do the merging in each function, for example, in this, when I merge these two sorted arrays into one sorted array, it will take in total n space. So that is the space which is needed at max in each recursive function. So the space complexity should be log n plus n is O of log n. No, sorry, O of n. Okay, so that being said, let me start the implementation. So what I need to do is, firstly I will define the recursive function. So in way, I will give the I will make sure that I will give nums, and I will make sure that the range load height should be sorted in this array. Oh, sorry. I've changed my mind. I will return another array. Yeah. That being said, in the main method, I will return. Oh, and if that being said, I don't need to pass low and high. So then what I should do is the base case, if there's only one element, I will just return. Oh, but I said I will copy this so that I don't. Yeah, as a contract, I said I will return new array, so I will initiate a new array. Then otherwise, so if there is more than two element or two element, I will pick the first three middle. But just in case, if low and middle, if the case high is row plus one, like 2 and 3, middle position should be 2 in with this calculation. So I would say I will split into these two sub-ranges, and what I can say is each of these have at least rank 1, as I've shown you, as I've told you. And that being said, I will get the sorted array by calling the recursive function. Then I will sort this to arrays. Yes. Okay. I will continue until each of them, either of them is still in the range. In this case, I will add I2. So in this case, I2 is already exhausted. I mean, array nums2 is already exhausted, so I will pick nums1. I will increment I1. Then otherwise, if number from nums1 is smaller, then I will pick it. Otherwise, I will pick num from I2, nums2. I will increment I2. Yeah, and that's it. Okay, so this is my implementation. Because I don't have enough time today, let me skip the working through. Never submit. I do this QuickSort selection and implementation. Never try again. I see. So because I gave nums as sub array which should be sorted. Good. I should. So this low is 0, always 0, high is rank nums minus 1. And 3, low is always 0, and high is I don't have to take care because good. I never submit my code. Okay, accepted. Okay, so yeah, my MergeSort approach is already accepted. Okay, so let me quickly wrap up my today's practice. So this question was sorting an array, and I introduced two solutions. The first one was QuickSort approach. And basically, this is the kind of solution which uses the recursion with partitioning. And the time complexity is average n log n, but in the case, it should be n squared. And I introduced two optimizations. I can avoid that. And the other approach I introduced was MergeSort. So MergeSort is also the kind of recursion plus merging two sorted arrays in its core. Yeah. Yeah, so that's it. It takes also n log n time. Okay, so there is one more algorithm to sort an array in n log n time, which is deep sort. Yeah, but I don't include it in this video. Maybe someday I will practice it and take a video. So please looking forward to it. And just in case, I will also add that this is QuickSort is unstable sort, and MergeSort is actually stable sort. So what I mean by stable sort is think of the same number, multiple same numbers exist in the array, like 1, 2, 2, 3, 1, 2, 4, 5. And if I take like a 2 after sorting, it can sustain the original order, or it cannot sustain the original order. So, and in the stable sort, the order which appeared, the order that the same number appeared in the original order is sustained after the sorting. And in unstable sort, the numbers, the order that the same number had appeared in the original array will not be sustained necessarily. So that's the unstable sort. Yeah, in the MergeSort approach, it's stable. And in QuickSort approach, in my implementation, it's not unstable. I don't cover, dive deep into that stuff today, but I just quickly added it. Okay, so let me finish my today's video with this. Thank you so much. Bye.